Hi everyone, welcome to my YouTube channel. If you haven't subscribed, please subscribe on the subscribe button below. Okay guys, today we are going to be talking about the materials treatment. Okay, by the material treatment, this is where a steel or an iron is being heated to achieve a desired result, such as hardening or softening of a material. Okay, the process of heat treatment involves heating of a material, holding it and cooling it down. Okay, on the heating process, we are going to be looking at the temperatures each heat treatment uses, the time a material is being held, and the medium of cooling and rate of cooling of a material. Okay, firstly, let us look at the material properties so that we can know which materials undergo a certain type of heat treatment and why. Okay, we know that the pure iron is ferrite, soft and ductile with considerable strength. With the addition of carbon, it becomes a hard brittle compound called iron carbide. Adding more carbon causes more iron carbide or pellite to be produced, thereby reduces the ferrite until it reaches the content of 0.9% and the whole structure becomes pellite. Steels are being heated to give it different properties of hardness and softness. This depends on the amount of carbon in the steel. The steels are heated to a temperature in which the carbon is in a solid solution, held until transformation is complete, and then put in a cooling medium in order to harden them. We heat treat the materials to improve their mechanical properties. Okay, now let us look at the carbon content range for each material. For low carbon steel, we have a 0.3% carbon content. For mild steel, we have 0.4% carbon content. For high carbon steel, we have 0.61% to 1.5% carbon content. And for cast iron, we have 3.0% to 3.7% of carbon content. Okay, now we are going to look at the types of heat treatments. Okay, we have 4 types of heat treatment, which is annealing, normalizing, hardening, and tempering. Okay, on annealing, we have a kind of anneal which is called a spheroidizing anneal, and for hardening we have a process called austenizing. Hardening is divided into different kinds, which is work hardening, case hardening, nitriding, carburizing, flame hardening, and induction hardening. And under tempering, we have 3 different kinds of tempering, which is low temperature tempering, medium temperature tempering, and the high temperature tempering. Okay, we're now going to look into detail each type of heat treatment. Okay, for the annealing process, this is where we use a cold work material. By cold work, we mean that the material has undergone the process of plastically deforming or shaping below its recrystallization temperature. And by recrystallization, we mean that the material has become more workable. For steel, the recrystallization temperature is between 400 degrees Celsius to 700 degrees Celsius. Okay, the annealing process undergoes 3 stages. Okay, we're gonna look at each stage. At stage number 1, we have a recovery. This is where a previously cold work material is used, whereby the relief of some of the internal strain energy takes place at low temperatures. And stage number 2, we have recrystallization. This is the formation of a new set of strain-free within previously cold work material. Recrystallization of a material takes for this long. We have 50% of material recrystallizes in 1 hour time. And lastly, we have a grain growth stage. Here, there is an increase in average grain size. The microstructure after annealing contains a coarse ferrite and pellite. Okay, we have discussed that under annealing we have a process called spherodizing. This is the annealing process used to soften tools, making them easier to draw and machine. And their holding time varies from 15 to 25 hours. Okay, we're now going to look at the annealing process furthermore. Okay, here the heat treatment undergoes 3 stages as we have discussed before. That it undergoes the heating process, the holding stage, and a cooling stage. For annealing, the material is being heated between 30 and 40 degrees Celsius above the upper critical temperature, and the material is being held at constant temperature for quite some time, and cooling is allowed inside the furnace, and it is happening very slowly. Okay, we're now going to look for the purposes of annealing. Why do we anneal a material? We anneal the material to relieve the internal stresses and refine grain structure, to reduce hardness, increase machinability, and we increase the ductility of a material. Okay, we're now going to look at another type of heat treatment, which is normalizing. Okay, normalizing also uses a cold work material. Here, the material is being heated between 40 to 50 degrees Celsius above the critical temperature, and it is being held for about 15 minutes. Cooling is allowed slowly at room temperature, which is usually in air. Okay, why do we normalize the material? This is the purposes of normalizing. We normalize a material to remove the internal stresses and restructure a material grains, increase the hardness of a material, increase its strength, and increase machinability. Okay, now we're gonna look at another type of heat treatment, which is hardening. Hardening, okay, only high carbon steel can be hardened and tempered. Okay, the high carbon steel, we have looked at the carbon content of each material. So here on the hardening, we can only harden the high carbon steels. The hardening process goes like this. From heating, the material is being heated between 720 to 900 degrees Celsius above the critical temperature, and it is being held at a constant temperature for a specific period of time. Cooling here is allowed by quenching. By quenching, we mean that we dip the material into water, oil, or a polymer bath. Okay, under hardening, we have discussed that we have austenizing process, which is the hardening process used for steel and other ferroalloys, whereby material is being heated long enough for transformation to take place. The material becomes hardened after it's being held for this time. Okay, we're now going to look at each kind of hardening into detail. Firstly, we have a work hardening type. Okay, work hardening, also called a strain hardening. Here, the metal is cold worked, which means it is shaped below its recrystallization temperature and strengthened by plastic deformation. Okay, why do we work harden the material? Here are the purposes of work hardening. We work hard a material to increase its hardness, improve the strength of a material, which means the material can elongate, compress, bend, and twist. Okay, now let us look at another kind of hardening, which is case hardening. Here, case hardening, it is used to harden the surface of a material with a heat-resistant material such as fire clay, cast iron, or heat-resistant nickel iron alloys, while allowing the metal underneath to remain soft. Under case hardening, we only harden the surface of a material. Okay? The purpose of case hardening. We case harden the material to reduce the surface wear of parts without losing the core toughness of a material. Okay, now let us look another kind of hardening, which is nitriding. Okay, by nitriding, this is where a steel is heated above 500 degrees Celsius and ammonia is circulated in an airtight container. Okay, why do we nitride the material? This is the purpose of nitriding. The ammonia forms the nitrides on surface of a material, which increases the hardness of the component. Okay, now let us look at another kind of hardening, which is carburizing. By carburizing, this is where the steel or iron is heated in the presence of carbon-bearing material such as charcoal or carbon monoxide, whereby iron or steel absorbs the carbon. Okay, we carburize a material to increase the hardness of a material. Okay, we're now going to look at another kind of hardening, which is flame hardening. Okay, flame hardening, this is where the surface which is to be hardened is heated by the oxyacetylene flame. The specific parts of the surface can be easily hardened by this method. Here on our picture we have this heating torch from our oxyacetylene. This is the flame into our material here, and this is quenching water. We are cooling our material using medium, which is water. Okay, now let us look lastly another kind of hardening, which is called an induction hardening. This process is based on the application of electric AC power into the coil to surface harden the material. As we can see here on our picture, this is our material here, and we put this electric AC power into the coil. This is the coil here, put on our material to harden it. Okay, now let us look at our last type of heat treatment, which is called tempering. Okay, tempering, this is the hardening process that uses 3 different kinds of tempering, which are low temperature, medium temperature tempering, and high temperature tempering. Here, the material is heated below its critical temperature, depending on the kind of temperature we are using. If we are heating at low temperature tempering, we're going to be using the material heated between 100 to 200 degrees Celsius below its critical temperature. And if we're using a medium temperature tempering, the material is going to be heated between 200 to 500 degrees Celsius below critical temperature. And if we're using the high temperature tempering, our material is going to be heated between 500 to 700 degrees Celsius below the critical temperature. And then after heating the material, it is being held at constant temperature for about 1 to 2 hours. Here, the cooling is also done at room temperature, usually in air. Okay? The hardening process follows the hardening process. After hardening the material, we then temper it. Okay? Now we're going to look, why do we temper the process, the material? Okay? Purposes of tempering. From hardening process, the material comes out more hard and brittle, which is not suitable for the engineering application. So tempering makes it suitable by reducing brittleness and increased ductility of a material. And this increases the machinability of a material. Okay? Now we're gonna look at the applications where we apply heat treatment. Okay? We heat treat on the engineering applications. We heat treat the gears, the pumps, the engine parts, which are cams, rings, bearings, shafts, etc.